Okay, so the next two examples that we're going to work through are actually really important ones. They give us an equivalent statement to the conditional and an equivalent statement to the negation of the conditional that's useful for stuff we do later. So to start with, we want to show that the conditional P implies Q is actually equivalent to this disjunction, not P or Q. And remember, the way that we show that two statements are equivalent is we show that their truth tables give us identical truth values for these two statements for all possible combinations of truth values for the component statement. So again, let's take a look at our truth table for the conditional. It's done on this page. Remember, the conditional was true in every case except for when P is true and Q is false. If I can construct a conditional, a truth table for this statement here and show that this statement is true for all cases except for when P is true and Q is false, then I will have shown that these two statements are equivalent. So to construct that, we need columns for P and Q. I need a column for not P. And then finally, I need a column for not P or Q. Here's my columns. We know that we have true, 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 false, false, true, false, false. These are always the same. Not P from this column is going to be false, false, true, true. Now we're looking at a disjunction, and remember, disjunctions are only ever false if both statements are false. They're true anytime at least one of those statements is true. So we're comparing Q and not P, these two columns here. As long as I can find a true statement in either of these columns, or potentially both, this will be true. So there's a true statement, that must be true. These are both false, so that makes this false. There's a true statement, that makes this true, and there's a true statement, that makes this true. This final column is identical to what we just saw for the conditional, so that proves that these two statements are equivalent to each other. Anytime I have an if-then statement, if P then Q, I can swap that out for the statement not P or Q. They're equivalent. Okay? Now with that said, we can do this next example, which says that we want to determine the negation of a conditional statement, or in other words, we want to determine an equivalent statement to it. So this is going to be kind of interesting. It's going to feel a little bit more like algebra here. And if you notice, we're going to use De Morgan's laws, or specifically one of De Morgan's laws, in this process. So the we're not going to use any truth tables or anything like that. The negation of the conditional P implies Q looks like this. The negation of P implies Q. Okay. Now in the previous example, we just showed that P implies Q is equivalent to not P or Q. And the benefit of that is that anytime I see P implies Q in a compound statement, I can swap it out with this statement. So right here, where I have P implies Q,